Let's dive right into this explainer because today we're looking at a genuinely fascinating engineering problem. We are going to see exactly how you can transform a purely text-based command line interface into a full-fledged video editor using Claude Code. If you've ever felt like traditional video editing is just completely disconnected from how developers actually prefer to work, you are absolutely going to love this breakdown. We're unpacking a brilliant experiment from XDA developers that completely reimagines a highly visual task as a pure code execution problem.
The creator hit the nail on the head with this central pain point. Manual video editing, dragging clips, slicing audio, syncing text, it often feels like a ridiculously tedious manual chore. And let's be real, in 2026, tasks that feel this repetitive are practically begging to be automated. Any developer knows that if you have to do the exact same manual action 50 times, you should probably just write a script for it. But how on earth do you script a creative, highly subjective process? Well, that's exactly what we're going to solve today.
So here's our pipeline for today. First, the video editing problem, then terminal setup and logic. After that, transcription-driven cutting, followed by programmatic asset generation, and finally, the final verdict. We're basically treating a creative task exactly like a software engineering and data parsing challenge.
All right, section 1, the video editing problem. Before we can even think about automating this 9-minute talking head setup, we really need to understand the messy raw input we're dealing with.
The thing is, the creator doesn't just film neat, perfectly organized clips. The raw input here is a single, continuous 9-minute take. Instead of stopping the camera for every single mistake, they just repeat a sentence over and over until the delivery sounds completely natural. Now, in data terms, that creates a massive array of redundant, noisy information. You might have 5 completely failed attempts, followed by just 1 successful string. Sifting through all of that visually on a traditional timeline is an absolute nightmare, which is exactly why a programmatic approach is such a game changer here.
Moving on to section 2, terminal setup and logic. You obviously can't just tell a terminal to make it look good. We need strict parameters. Notice the golden rule here. When I repeat a line, the last repetition is the keeper. The creator fed this absolutely crucial, logic-based prompt straight into Claude Code. This is so cool because it perfectly translates what is essentially a vibe-based human editing decision into a strict executable programmatic rule. Instead of asking the AI to somehow judge the emotional quality of the audio, it simply instructs it to parse the data for duplicates and then just retain the final item in any redundant sequence.
What's wild is that before touching a single file, the creator explicitly told Claude Code to act non-destructively and propose a plan. And it acted completely autonomously. It checked the system environment, realized essential dependencies like ffmpeg and a transcription tool were missing, instructed the user to install them, and only then generated this 6-phase roadmap. It essentially architected its very own CI/CD pipeline for a video file, guaranteeing that the original 9-minute asset was completely safe and never overwritten.
Okay, section 3, transcription-driven cutting. This is where we get into word-level slicing and how we actually execute a cut without any visual timeline.
To edit without a graphical interface, you absolutely need metadata. So, Claude Code integrated a tool called WhisperX, and this didn't just spit out a block of text, it generated precise word-level timestamps. By doing this, Claude transformed a really complex video cutting problem into a highly manageable text parsing problem. Suddenly, it could mathematically identify exactly where repetitive strings of text occurred, and then use those text timestamps to physically slice the video file.
But, no development process is ever without its bugs, right? During the initial rough cuts, the creator noticed that the stutters and false starts were quietly dragging themselves right back into the exported video. The issue? The transcription software was collapsing rapid, and I mean really rapid, repeats into single timestamps. The dataset just wasn't granular enough to actually execute the cut rule accurately. Now, instead of just giving up and throwing an error, Claude Code actually diagnosed this issue all by itself. It realized the transcription settings were flawed, so it autonomously retranscribed the audio using entirely new parameters, literally forcing every single stutter and repeat into its own isolated text chunk. It rebuilt the entire cut at the word level, successfully parsing out those redundant arrays. Honestly, it's a brilliant example of an AI agent debugging its very own data pipeline.
Section 4, Programmatic Asset Generation. Let's see what happens when standard command line tools fail, because cutting is one thing, but making it visually engaging is a whole different beast.
The creator really wanted those trendy, one word at a time, pop-in captions, but they hit a major technical roadblock. The specific version of ffmpeg installed on the machine actually had its text rendering capabilities completely stripped out. It simply could not draw text onto the video natively. In a standard workflow, this is exactly where a script throws a fatal error and just dies. But this perfectly illustrates Claude Code's workaround logic. Instead of feeling, the agent just decided to draw the captions itself, completely from scratch. It programmatically generated individual image frames for every single word, making the text bold, adding a thick outline, even highlighting the active word in yellow. It then layered these custom-generated image frames back over the video, syncing them perfectly to the WhisperX metadata. It literally built its own custom captioning engine on the fly.
And the agentic behavior didn't even stop there. Claude autonomously scraped the web for relevant B-roll images that matched the keywords in the transcript, dropping them into the timeline at the exact right millisecond. It intelligently caught and autocorrected transcription errors, like automatically fixing a misspelling to the correct brand name, Satape. But my absolute favorite part? When it realized it couldn't download sound effects from the web, it literally synthesized a soft whoosh and a light pop entirely from code, perfectly mixing them right under the B-roll. No way, right?
Finally, Section 5, the final verdict. Was all this technical setup actually worth it? Let's evaluate the final executable output. Just looking at the metrics, the agent achieved a massive data reduction. It took 9 minutes of raw, rambling footage and algorithmically sliced it down to a really tight 1 minute and 22 seconds. The captions, the synthesized sound effects, the B-roll, all of it was spot on. The only manual intervention required was exactly 2 minutes and 33 seconds of human QA cleanup, just to smooth out a couple of super tight cuts.
However, we definitely have to look at the trade-offs here. While the AI generated a near-flawless programmatic result, it came at a pretty high compute and time cost. You've got transcription, diagnosing bugs, re-rendering, image generation. All of that ate up a huge chunk of an afternoon, and the MacBook heated up significantly. A fast, experienced human editor using a traditional GUI probably could have scrubbed through and made those exact same cuts faster than the total render time it took the AI to process the whole shebang.
But focusing only on that trade-off kind of misses the larger point. As the creator notes, the real takeaway is that AI agents like Claude Code are no longer just for writing or debugging Python scripts. They are fully autonomous problem solvers. Give them a terminal and a logical framework, and they will happily dismantle and automate workflows that we previously thought were strictly visual or creative.
Which leaves us with this final thought to chew on. We've just seen a command line synthesize audio, edit frames, and cut an entire video based purely on text parsing and metadata logic. It really makes you wonder, what other traditionally subjective visual workflows in your own home lab or daily work are secretly just data parsing problems, just waiting to be dismantled by code? Thanks so much for joining me on this explainer, and I highly encourage you to start looking at your daily tasks through this exact same programmatic lens.